Okay, so this is the second half of our notes, and you guys have this page. You got this in class, and I didn't think we would get through it all. It was hopeful, but we did not. So we're going to go ahead and do it through a video so that we can move on next week when you guys come to class. This first two section on this notes, that was the video I gave you guys on those graphs that we put into our notebook. So we are kind of done with this section, and we're actually going to start right here where it says acceleration graphs. So right here, acceleration graphs. So if you look at the PowerPoint over here, it says a typical acceleration graph will have speed or velocity, remember, a change in direction, on the y-axis and time on the x-axis. Okay, so we're going to fill in our blanks that we have right here. So a typical graph will have speed or velocity. Those are our blanks. On the y-axis and time on the x-axis. Blank represent the object's acceleration or velocity. So here it says the lines. So the lines on the graph are going to represent the object's acceleration or velocity. So instead of having you guys create what these graphs should look like, I went ahead and put in the examples for you to kind of help move this along. So as you can see, right here we have velocity, and I believe that is reading in meters per second. So that would be a speed unit, so meters per second. And then time is right here on the x-axis. So I'm going to mark, this is our x, and then we have, this is our y over here. So the lines that we are talking about that represent the object's acceleration or velocity. So these are the lines that we're discussing here. Okay, so any lines on the graphs are going to represent whether an object is accelerating or its velocity, which would be a change in direction. Okay, so now we're going to move down to the constant velocity. We'll go green on this one. Okay, constant velocity. Oh, there's our graph. We just looked at that. Okay, constant velocity. When the velocity of an object remains the same, its rate of change does not increase or decrease. Okay, so velocity goes in our blank. So when the velocity of an object remains the same, the rate of change does not increase or decrease. So here's an example. If you look at down here, it says 10 meters per second at time 1 second, and then 10 meters a second at the time 2 seconds. So what that's saying is that at these two different times, the rate of the object did not change. Okay, looking at the chart over here, what we're looking at, our flat line right here. So we're talking about the velocity on our object did not change through time. Okay? All right, let's look down at our next one. There we go. Constant acceleration. Okay, on this one, acceleration is constant at any point on the line. So here are some examples. 4 meters per second squared at 1 second and 4 meters per second squared at 2 seconds. So if you look at the graph on that, as our graph is going up, we're seeing that the acceleration is constant. Okay, so that means it's not changing, and we know it's not changing when we calculated and we looked at the velocity and we looked at the time of the object. We saw that nothing was changing here. Okay, so that would be a constant acceleration. And there's one more thing that we need to add into our notes right here. The steeper the slope, the greater the acceleration. Okay, so that looks like those kind of go together, little relationship with that. So the steeper the slope, the greater the acceleration on that one. Okay, all right, so let's go to our next section, and we're looking at increasing acceleration. So the top of our next page. Okay. Increasing acceleration. All right, on this one, curved line indicates that the acceleration is not constant. And we learned that on the notes that we did the other day. When we had a curved line, we knew that what was happening was the acceleration was increasing. Okay, so the example, a car starts to move slowly and gradually increases its speed. So the steeper the line, the greater the rate of acceleration. Okay, and we can see that right here where we have this gradual line going up, and then this little line right here shows a slower acceleration, and then right here we have faster acceleration. And the reason that is the line got steeper. Okay, so that's why we have faster acceleration. The line becomes steeper. Okay, and the next one is a think, pair, share. So we don't really have that since you're working on your own for this one, but we're going to go ahead and look at this, and I want you to pause this video and describe the motion of the student shown in this graph right here. So describe what's happening here, and then come back on and we'll check to see how you did, okay? So pause it and try to write it out here, and then come back and check it. Okay, now you guys are back and you've had time to look at your graph. I went ahead and labeled mine by each little section. So I have A, B, and C. So then over here, I wrote out what I felt was taking place at A, B, and C. So for A, I said my object accelerated at a slower rate for 40 seconds. So we know we're accelerating because we're moving away from our point of origin right here. But because that accelerated also is telling us because we have a curved line, but it's not very steep, it's very gradual. So that's how we know it's at a slower rate. On B, we had our object rested for 20 seconds. So here again, we changed no speed, we changed no direction, and time continued. And we started resting at 40 seconds. We ended resting at 60 seconds. So that's a 20-second difference. So that's how we know our object rested for 20 seconds. On C, this line right here, we saw that our object moved at a very constant acceleration. So again, we're accelerating because we're moving forward. And as you can see, the line is constant and in the direction that it's moving. So we said it was moving for a total of 20 seconds, and I got the 20 seconds. So we started accelerating at 60, and then if you kind of come down, it stops at 80 seconds. So I'm going to say that right here, the difference between 60 and 80 is 20 seconds. So we're going to say it went on for 20 seconds, and that's when we stopped recording the object's motion. Okay, so this is what you should have, and the words that we are looking for here is accelerated, rested, and constant acceleration for that one right there. Okay, so the final piece that we are going to look at, it's kind of a little recap of everything we've done. On this one, this is more of your acceleration graph. Okay, so if you go back and look, it's going to touch on those, hold on. There we go. There it is. It's a little easier to see. So this acceleration graph is showing velocity, okay, which is your speed, and then we have our time on the x-axis. So that's x and that is the y. So if we're looking at the different types of lines that we just went over, they're reminding us what we have here. So our straight line at an angle moving up right here is a constant acceleration. Our changing acceleration is one where it gradually increases and it's a curved line. Curved line shows our change of acceleration, and anytime we have a constant speed, because we have speed right here, it is moving in a constant, so we have time. Okay, so I think this kind of concludes our notes, and you are good to place these into your notebook. And if you're working on your vocabulary, use these notes to help you with the vocabulary as well. See you guys later.